Hello students, I hope you have read the first part where I have discussed introduction about pressure. Today we will be studying mechanical properties of fluids, Pascal's law. So Pascal's law is named according to the famous scientist Blaise Pascal. He is a French scientist, and what is stated that pressure in a fluid is same at all points if they are at the same height. Now, let a right angle triangle prism, which is immersed in a glass tumbler, the three faces of the prism, as you can see from the figure, ABED, ABFC, and ABC. This prism is immersed in a liquid, in a tumbler. Now, the fluid in this tumbler is at rest. So you can see I have drawn with this yellow figure the force acting on the sides. They are represented by FA, FB, and FC. Now, the main thing to note that the force FB that is acting on one of its sides, it can be resolved into two components, the vertical and the horizontal. The vertical component is FB cos theta and the horizontal component is FB sin theta. Now, let us consider the prism is very small, so the height is considered same at all points on the prism. Now, effect of gravity is also considered same at all points. Now see, we have defined that pressure in a fluid is same at all points if they are at the same height. Now we can define now in this way also, that is the increase in pressure at any point of the enclosed liquid which is in equilibrium and at rest is transmitted equally to all other points of the liquid and also to the walls of the container, provided the effect of gravity is neglected. Now let FA, FB and FC, this is the normal force acting on the prism. I think you have drawn the picture of the prism, and the consecutive forces due to these onto the pressures due to these forces, they may be represented by PA, PB and PC, and they're acting on the sides which are having the area AA, AB and AC respectively. Now let us draw the prism over here also, so that you can understand very easily. Now we have seen as we have resolved the components of FB by resolving the components of FA and FC, or by taking the direction of FA and FB, we can see the direction of FA is opposite to FB cos theta and direction of FC. So what we can write is that FC is equal to FB sin theta. FA is opposite to FB cos theta. FA is equal to FB cos theta. And from the geometry of the figure, you can write AC is equal to AB sin theta and AA is equal to AB cos theta. So we can get a relation from here by dividing this equation 1 by equation 3. What we'll get, FC by AC is equal to FB by AB. And again, dividing equation 2 by equation 4, what we'll get is FA by AA is equal to FB by AB. Therefore, we can see that FA by A is equal to FB by AB is equal to FC by AC. So what is this FA by A? These are the pressures. So PA is equal to PB is equal to PC. Thus, pressure exerted is same in all direction by the fluid. Now we consider a horizontal liquid of uniform cross section. This liquid is of uniform cross section. So what you do, we can observe from here that if the pressure were not, so let us draw the figure at first. This is horizontal, suppose this is the horizontal fluid, it is in the shape of a bird, and pressure from the fluid is acting outwards and outside as at most. So this means that there is a difference in pressure, and pressure is unequal at different parts of the fluid, and this makes the liquid to flow. So there is some net force acting on it. There is a difference in pressure means there is some net force acting on it. Now, if it doesn't flow, means the forces are in equilibrium at both inside and outside. Now, horizontal force, you can see this is the horizontal force exerted at ends. This must be balanced, or pressure at the two ends must be equal. This proves that for a liquid in equilibrium, the pressure is same at all points in a horizontal plane. Thus, no flow means pressure is same anywhere in a horizontal plane. Okay, see you in the next class. Stay tuned. If you like my video, please subscribe.